Hello, today I'll be covering section 0.1, Operations on Real Numbers. The objectives of this section are to add, subtract, multiply, and divide integers, simple fractions, and decimals. Addition and subtraction. We can visualize addition as moving to the right on a number line, and subtraction as moving to the left. Using this concept, visualize and perform the following operations using a number line. A 5 plus -3. The first thing we're going to do for this one is this is equivalent because we have two operations right here. That's 5 minus 3. So to visualize this on a number line, we start at 5, and because it's subtraction now, we move left 3. 1, 2, 3. So we get 4, 3, 2. So 5 plus -3 is 2. B. There are no double operations, so I can go straight to the number line. -7 plus 4. So I'm going to start at -7 and go to the right 4. 1, 2, 3, 4. So that's -6, -5, -4, -3. So -7 plus 4 equals -3. See? -3 minus 5. So we're going to start at -3. And because it's subtraction, I need to move to the left 5. So we get -3, -4, -5, -6, -7, and -8. So -3 minus 5 is -8. D, -2 plus -6. Well, we have the double operations again, so plus a negative is the same thing as minus. So this will be -2 minus 6. So go to the number line. Start at -2. Since I'm subtracting 6, that means move to the left 6. 1, 2, 3, 4, 5, 6. And we end at -8. So -2 minus 6 is -8. E, 8 plus 7. So starting at 8 and going to the right 7. And if you fill that all in, we'll end up at 15. So 8 plus 7 equals 15. Again, we have a double operation here. So 5 minus -2, that's the same thing as 5 plus 2. So we go start at 5, to the right 2. So 5 minus -2 is the same as 7. Note, when adding a positive and a negative number, the sign of the answer depends on which number is bigger, the positive or negative one. And subtraction is just addition of the opposite. That is, A minus B is A plus -B. Example 2. Perform the following operations if possible. Well, 2 dogs plus 3 dogs. That means we have a total of 5 dogs. 4 elephants plus 3 giraffes. Well, that means we have 4 elephants and 3 giraffes. I can't combine them, so not possible. Four x's plus 9 y's. Just like in B, x's and y's are different, so I can't combine them in any way. So this one is also not possible. Six elephants plus 3 elephants. This one is possible. We end up with 9 elephants. E, 3 x's plus 9 x's. X's are the same, so we get 12 x's. Now F is the best way for me to understand anyway why you need common denominators in order to add fractions. Because if you read them in words like 2 sevenths plus 3 sevenths, I can see that sevenths are the same. So we end up with 5 sevenths. Went too far. Okay. -3 degrees plus 10 degrees. That'll be 7 degrees. Now, 2 quarters plus 3 dimes. They aren't the same thing, but I know they both represent money. For example, 2 quarters is the same thing as 50 cents. And 3 dimes is the same thing as 30 cents. So 2 quarters plus 3 dimes is equivalent to 50 cents plus 30 cents, which is 80 cents. So even if you don't start out with like things, sometimes you can convert them into like things. Notice, you can only ever add things that are the same thing, and when you add the same things, you get the same things. Sometimes you can convert different things into the same things so that you can add them. For example, the quarters to dollars or miles to kilometers. Properties of addition. The number 0 is the additive identity of real numbers. That is, a plus 0 equals a for any real number. In other words, when you add it to a number, that number stays identical to itself. It doesn't change. Every real number has an additive inverse, or simpler terms, we call this opposite. The sum of any number and its inverse is 0. Finally, we say that addition is commutative. That is, a plus b equals b plus a for any a comma b in R. So a little side note here. This just means a and b are real numbers. Where this double-backed R, it's called, is the symbol for real numbers. Addition and subtraction of fractions. Big idea. Use common denominators to rewrite fractions as same things. Perform the following operations and write your final answer in simplest terms. So 1/7 plus 3/7. they already have a common denominator, so that'll be 4/7. So since the sevenths are what are in common, that's the thing that stays the same. So you don't add the denominators, you just keep them the same. You add the numerators though. B, 2/3 minus 1/3. Well, again, they already are the same, so that's 1/3. Nine 25ths plus 4/10. Now these do not have a common denominator. A simple technique for finding the common denominator is you start with the larger one and compute its multiples until you see a multiple of the smaller one. So for example, between 25 and 10, 25 is bigger, so I'm going to go 25. And then 25 times 2, that's the next multiple, that's 50. Oh, 10 goes into 50, so 50s are LCD, it's called. So what that means is I need to rewrite both 25 and 10 with a denominator of 50. Now, I highly recommend when you do this is you just write both the denominators of 50 there. I have students try to do it one at a time. Just write it out, blank numerators, it's okay. Well, now 25 times what is 50? Well, 2, we already said. So since I did 2 times 25 to get 50, we also need to go 2 times 9 to get an equivalent fraction, so that'll be 18. Now 10 times what is 50? Well, 10 times 5 is 50. And again, whatever we do to the bottom, we have to do to the top. And 4 times 5 is 20. Well, now that they are like things, we can add them, and we get 38 over 50. But then don't forget, you can reduce fractions. So since 38 and 50 are both even, I'm going to rewrite them. Well, 38 is 2 times 19. 50 is 2 times 25. So the 2's cancel out, leaving us with just 19 over 25. Okay, D. Now we have 9 and 12. So again, I'm going to start with the bigger one. So 12. 12 times 2. 12 times 3. And there's our answer, 36, since 9 also goes into 36. Okay, so 9 times what is 36? Well, 9 times 4. So then I need to go 4 times 4, which is 16. And 12 times what is 36? Well, 12 times 3. So I need to go 5 times 3, which is 15. And then 16 plus 15 is 31 out of 36. And we're done because 31 and 36 have no common factors. E and F. 2/3 plus 4/5. Well, again, I'm going to start with the bigger one. So 5. 5 times 2. 5 times 3. Well, we get 15. So 3 times what is 15? 5. So I need to go 5 times 2, which is 10. And 5 times what is 15? Well, 3. So 5 times 3. So 4 times 3 is 12. So we get 22 over 15. And there we go. They have no factors in common, but the numerator is bigger than the denominator, so this could be rewritten as a mixed number. We'll leave it as an improper fraction right now. Okay, 3/4 and 1/8. Again, I'm going to just start with the 8. Oh, and I can be done because 4 already goes into 8, so there's nothing more to do. So it's 2 times 4 is 8, so we go 2 times 3, which is 6. And then 8 times 1 is 8, so we go 1 times 1, which is 1. And then 6/8 plus 1/8 is 7/8, and we cannot reduce that. Note, we will be discussing strategies for working with fractions and finding common denominators in Unit 2. Addition and subtraction of decimals. Big ideas. Line up the decimal places and add accordingly. For subtraction, begin by ignoring the signs. Subtract the smaller decimal from the larger decimal after lining up the decimal places, then apply the sign, positive or negative, of the larger decimal. Perform the following operations. So part A. So I'm going to line up the decimals. So we get 2.17 and 3.451. Notice how after I line those decimal points up, I have two numbers to the right in the first number and only three to the right in the second number. I highly recommend adding what are called filler zeros. You can only add filler zeros to the right of the decimal point, not to the left. And then we're going to add these together, right to left. 0 plus 1, 7 plus 5 is 12, carry the 1, 1 plus 1 plus 4 is 6, and 2 plus 3 is 5. Thus, 2.17 plus 3.451 is 5.621. Okay. 13.145 minus 5.3. Since we're subtracting, you really want to take the larger absolute value number on top, smaller absolute value number on the bottom. Well, 13 is larger than 5, so 13.145 will go on top, and 5.3 will go on the bottom. And again, I'm going to add two filler zeros. Now we subtract these two numbers in this order. So 5 minus 0 is 5. 4 minus 0 is 4. 1 minus 3. Well, I can't do 1 minus 3, so I go over to the 2. Borrow 10 from it so that I can carry that 10 over to the 1, and we get 11. 11 minus 3 is 8. 2 minus 5, well, I can't do that, so borrow from the 1. Get 12 minus 5, which is 7. Then since this was subtraction, which number was bigger? The 13 we already said, was that positive or negative? It was positive, so our answer is positive 7.845. Now C, 0.35 minus 6.7. So again, you take the larger absolute value and put it on top, which is the 6.7, minus 0.35. I need one filler zero. You subtract the numbers in this order. 0 minus 5, I need to borrow. 10 minus 5 is 5. 6 minus 3 is 3. 6 minus 0 is 6. Now, which number was larger? The 6.7, which was negative. So that actually means our answer is negative 6.35. Remember, the only things you can ever add are the same things. That'll be it for this part of section 0.1. Stay tuned for part 2 of section 0.1.